In this video, we apply Markowitz portfolio selection in order to demonstrate how to construct an efficient frontier and identify the optimal risky portfolio. The idea behind Markowitz portfolio optimization is that it applies the theory of diversification in order to construct the mix of optimal risky portfolios. That is, Markowitz portfolio optimization helps us to come up with what we know as the efficient frontier. Now, the efficient frontier of risky assets are those combination of assets or those portfolios that each investor will try to achieve in order to maximize their utility. So a portfolio is considered to be efficient if it is the portfolio that has the highest return for any given level of risk, or alternatively, it has the lowest risk for any given expected return. So we can think about the portfolios that lay along the efficient frontier as those being the combination of portfolios that have the highest risk and lowest return. That's why they're utility maximizing for investors that have mean variance utility. So when we're going about constructing our optimal risky portfolio, we know that there are a selection of different portfolios that we could choose along that efficient frontier. However, we need to select one of these portfolios as part of our security selection decision and then combine that risky portfolio with the risk-free rate as our asset allocation decision. Therefore, what this means is that of all the possible portfolios along the efficient frontier, we need to select one risky portfolio. And there is one risky portfolio that should be preferred over the rest. That is known as the optimal risky portfolio. The optimal risky portfolio is the portfolio that maximizes the Sharpe ratio of an investor. So that's the one portfolio along that efficient frontier that has the highest possible Sharpe ratio. While we know investors have different preferences toward risk, those preferences can be catered for in the asset allocation decision. Hence, we don't need to consider the degree of risk aversion when coming up with the security selection decision. So let's have a think about how we can identify the efficient frontier and particularly identify this optimal risky portfolio for a simple example where we have two assets. So in this particular case, our two assets are BHP shares and Foster's Group shares, and the assumptions for each of these assets are provided on the screen. What I can do is I can combine those two assets together in order to come up with a range of different portfolios. So as we move from the top of this table down the bottom, all we're doing is we're reducing the weight in BHP shares and increasing the weight in Foster's. Now, the sum of the weights will always be 1 because this is simply a two-asset portfolio. Using our portfolio calculations of expected return and risk, we've got the expected return and the standard deviations of returns for each of these portfolios. And some interesting things that we can observe here. We can see that because the expected return is simply just the weighted average of the parts, the expected return will change in a linear fashion as we change the weightings. Now, the standard deviation of returns will also change, but it will not change in that same linear fashion because we know that the standard deviation of a portfolio is not simply the weighted average of the parts. In fact, we can see the standard deviation decreasing down to some point around here where this red dot is, but then the standard deviation starts increasing again. So the portfolio that has the lowest risk, or we know this as the minimum variance portfolio, is somewhere in here, somewhere between 20 and 30% invested in BHP stocks. Same applies with the Sharpe ratio, which remembering is our excess return divided by standard deviation. Our Sharpe ratio increases to some point, and that point being around the red dot, and then it starts decreasing again. So the portfolio that maximizes our Sharpe ratio, our optimal risky portfolio, will be some point between 70 and 60% invested in BHP shares with a balance in Foster's Group. So why are these 2 points I've identified in red really important to our construction of an efficient frontier? Well, if we think about our efficient frontier, it looks something like the line I've drawn on the board here. In fact, what this line is it is a plot of the expected returns and the standard deviation for each of the combinations of BHP and Foster's Group shares as we calculated before. So it's just plotting each of these portfolios along an axis. Some important points to note is that this point I've identified here is where our efficient frontier starts, because from this particular point through the rest of the range of possible outcomes, They are all the different portfolios that have the highest expected return for a given level of risk. We don't want to be investing down this bottom half because down here we've got portfolios that for the same level of risk we can earn a higher expected return. Now why this point here is important is the start of the efficient frontier we can actually identify because it's the point that's the furthest left on this x-axis, or it is the point that has the lowest standard deviation of returns. It is the point that we know as the minimum variance or the minimum risk portfolio, which was why I highlighted this dot in red previously, because that point is the start of our efficient frontier. We then move along and we have some point along this axis where we've got the combination of our assets results in the maximum Sharpe ratio, where we maximize the Sharpe ratio, and I've identified the relative weightings of each of these portfolios on the screen here. Now, what do we know about the portfolio that maximizes the Sharpe ratio? Well, there's one key characteristic. If we take that portfolio and combine it with our risk-free rate, we're going to assume the risk-free rate of interest is 5%, we can come up with a capital allocation line. Okay, that capital allocation line will look something like the following. Okay, so the blue line here is the capital allocation line for combining the minimum variance portfolio with the risk-free rate. So it's the combination of those assets that we can come up with. The yellow line is the asset allocation decision where we're combining our optimal risky portfolio with the risk-free rate. So our optimal risky portfolio, the portfolio with the maximum Sharpe ratio, will be the portfolio where this capital allocation line is tangential to the efficient frontier. So it just comes along, kisses the efficient frontier and continues to move outwards. It is going to be the point where the capital allocation line has the highest gradient. And the reason for that is that the Sharpe ratio is simply just the gradient of the capital allocation line. So maximizing Sharpe ratio is akin to maximizing the gradient of our capital allocation line, which is important because we can see that along this yellow line here, it provides us with complete portfolios that are clearly superior to the blue line. Okay? They've got higher expected returns for each given level of risk. So it makes sense for the investor to take that optimal risky portfolio and diversify or undertake asset allocation by combining it with the risk-free rate of interest. That's a simple example where we've got two assets. What if we generalize? What if we go to more than two assets? In this particular case, I've got 7 assets. And I'm assuming that these 7 assets have expected returns and standard deviations of returns in the manner plotted on the diagram on your screen. Now, where we have multiple assets, what we know is that the efficient frontier looks like the following. So we've got here our y and x axis, and I'll make an important note here. It's important to note that on my y-axis, even though I can observe data based on historical returns, when we're dealing with our efficient frontier, our y-axis is expected returns. It's forward-looking. It is not historical returns. So we need to calculate expected returns using some model such as the CAPM. Our standard deviation of returns, technically that's also expected standard deviation, but we're assuming that our risk is constant across time, so we're going to use historic standard deviation as our measure of expected future standard deviation of returns. So in terms of our 7 assets, what we can do is we can take those assets. So asset 1 might have the following expected return and standard deviation, asset 2, and we can combine those two together to get this mix of potential portfolios, and we would have an efficient frontier that would start at the minimum variance and move through to asset 2. What happens if we added a third asset? Well, with a third asset, we can come up with similar combinations of portfolios, and so on with additional assets. And we can also then take a point, or so this purple point here is where we've already combined asset 1 and asset 2, and we can take that point and further diversify with asset 3, or we can come up with a 3-asset portfolio. And so on. We can come up with a whole range, such that the combination of all those portfolios will form this cloud shape. So we can see the cloud starting to take form here, where we're getting all these combinations of, in this case, just combining these 4 assets and all the possible iterations of 1 through to 4 asset portfolios, and the result is cloud. So the cloud is relevant because anything inside the cloud comprises our feasible set of risky assets. That is the combination of potential portfolios that the investor has available to them within this universe of stocks. However, the investor's not going to want to invest just anywhere. They still want to be on this efficient frontier. The efficient frontier, again, being those combination of assets that have the highest expected return for a given level of risk. Once again, the efficient frontier will start at the minimum variance portfolio, which is point A, and move along, and it will pass through some point, which is the optimal risky portfolio, and that optimal risky portfolio is going to be the point whereby we combine that optimal risky portfolio with a risk-free asset such that the capital allocation line is a tangent to that efficient frontier. And we know that that capital allocation line is clearly superior to the others, such as the yellow dotted lines I've drawn on the screen here, because investing along this black line, our black line being the combination of our risky portfolio and the risk-free asset, results in clearly superior options to other capital allocation lines that might be available to us. So that's the process by which we use the Markowitz portfolio selection model in order to come up with our optimal risky portfolio.